All right, we are live. Hello, hackers. Welcome to whatever date it is. We'll figure out what date it is in a second when I bring up the slides. The 20th. Someone claims it's the 20th on Twitch. Well, the slides agree. Boom. Okay. So let's roll. All right. We have 2 days to go until baby jail is behind us. In fact, with these 2 days to go, the lectures for reverse engineering have now opened up. So we have, if you go to the dojo, to this dojo, we go and we scroll down and boom, we see a debugging refresher course, which in retrospect, we should have launched with baby jail, given how heavily people have been using GDB, but now you'll actually have to learn. And then the reverse engineering module is ready to go for your perusal. And then the challenges will launch, of course, on Thursday. All right, let's take a quick look at where we are on the scoreboards, and then we'll go on to the meme review. So as always, Zamo's heading up the top of the scoreboard here for the full dojo one, followed by Ram, Richardo, Dorcellousness, and Death by Gunboat. So what title? Oh, the Twitch title says 365. That's fine. We'll fix it. All right. Anyways, a lot of new names on here. I recognize Zamo and Richardo from last week, of course, but it's really cool to see people pushing ahead and see new names on here, of course, and some of the old names still in that top 10 with full completion. It's also good to see. All right, so if we dig into sandboxing, see how people are doing so far. People are doing fairly well, except for, these later levels. Only 29 solves on level 18. It'd be nice to get those numbers up. I want everyone to have full solves. And this module's number one is Richardo. So that's our first non-ASU top place. Congrats, Richardo. Followed by Dorcelessness, Death by Gunboat, Alienor, and Sadeli. Great job. Awesome. All right, let's do some memes, and then we'll do some final thoughts on sandboxing. All right. So you may have noticed that the new levels that I was going to launch Thursday before class last week, then Thursday right after class, ended up coming out like in the middle of the next day in the morning. I tracked down the issues with the infrastructure. Actually, I had to rewrite the last challenge. It was going to be super neat, and one of the unintended, of course, there's with these levels that kind of build up in complexity, it's not rare that the solution for the last level can solve the previous levels as well, right? Just how these things work, especially sandboxing, because just different, less and more subtle ways that you can screw up making a sandbox, right? You noticed, one of the levels we just didn't unmount the old root. On the other levels, that was fixed, but there were other things that were wrong. But of course, the other things that are wrong, oftentimes are also wrong earlier. And this isn't just a problem with the jailbreaking, but it is especially a problem with this with the sandbox escape stuff. Now, ran into a crazy issue with the infra where GDB on my local machine was working. And one of the later levels, the intention was to use GDB in very clever ways to break out of the sandbox. But in the dojo, it wasn't. And it turns out that in their infinite wisdom, the developers of GDB broke GDB between version 9 of GDB, which shipped with Ubuntu 2004, and version 11, which ships with 2204, and is also the version installed at the dojo. And they changed it in a very subtle way of how it gets memory from a process in a way that would make it very, very, very difficult to solve that last level. So I changed it out with a different one. Which is a bummer, but it is how it is. So we finally launched it. So that's what we were doing. I wasn't just sitting around killing random people's Dockers. In fact, we hopefully people have experienced a lot less downtime. We've almost eliminated the downtime inherent with tweaking like module descriptions and stuff. All right. Immediately after the release of the new Sandbox Escape levels, Zamo swept them all. I think within like 7 or 8 minutes. It was there was a bug that I left open for. I was implementing one of the later levels, and the way that we generate these things, we have big templates that of hacking challenges that generate all sorts of cool stuff. And I screwed up the template, and I never went back and rechecked earlier, or rather, I inserted a new level 14. That's why we have 4 instead of 3. And then I never went back and rechecked the later levels to make sure that that bug was closed. It wasn't. Boom, immediate sweep. We went back and fixed it. And Zamo and Eleanor found even more bugs, some unintended, some intended. So we'll iterate on that, not this time because it's a little late in the game, but for future iterations. I think we'll end up with a lot more levels to really explore the different ways that they found to mess things up. All right. Hopefully everyone enjoyed writing cool shellcode. Sometimes shellcode that you haven't potentially written before, but I know that there's a lot of, again, unintended ways to cheese these things. And then 2, getting the fake flag. So who here got a fake flag when they expected a real flag? Nice. That's what we like to see. That's why we put the fake flag in there. We had a big discussion with Connor once upon a time. Do we want the fake flags, or do we just want no flag inside the jail? I think the fake flag is a good motivator. It's like, no? Maybe it's a demotivator? Maybe. Yeah. So that's fun stuff. Of course, we have a whole genre of chmod good memes. Chmod was very, very overpowered. It turns out, I mentioned last lecture, that Docker's combination is a combination of namespacing, which hopefully you've now kind of seen how namespacing can get you part of the way there, but you've also seen why seccomp is necessary. All of the different unintended solutions for these levels come from, probably we should have also shipped the seccomp eventually in the level progression to disable stuff like chmod. Of course, Docker can't disable chmod, so there's other more and more complete sandboxes that you can explore. And stuff like mount, disabling that would probably be good. All right. So yeah, the fake flag, I have this on a separate slide because I want to convey to you, please don't leave the jailbreaking module to the last minute. It's a different type of difficulty than shellcoding. Shellcoding is just very, oh, is anyone having trouble hearing me? Should I get a microphone? Everyone's good? All right. Shellcoding is difficult because something new, something different that you haven't necessarily maybe written assembly or before, etc. But shell coding has to do with x86, and you go to the x86 instruction listing, and it's everything you need to know. It's a nice, beautiful system that is perfect in every way, and that you can kind of learn about in one spot. Now, in Sandbox Escapes, you're talking about the Linux kernel, right? A massive piece of software where there are hundreds of system calls, thousands of different potential commands to explore, a million different ways things can go right or wrong. And it can be very, very, very hard to just sit down and solve that challenge. It's much easier to conceptually miss something, I think, in sandboxing. So don't leave it off to the end, because even for the easy ones, you could just be missing the thing, and it might take 10, 15 hours of bashing your head against the keyboard. All right. And then the genre of memes I always enjoy. x86 good, MIPS bad. I haven't seen this movie, but I think this guy's like a LARPer or something. But no, I'm just kidding. But it's good even if I don't fully get the reference. This is great because it's also technical, deeply technical. Null bytes disassembled to this in x86, to a memory write or memory, or an add to memory referenced by RAX, which is why does it disassemble to that? I don't know. That's just what the opcode for that is 0, and then all zeros are the correct segment register selectors that get you that instruction. That instruction is also why, typically, your shellcode will segfault if you just put zeros in there, if you fail to write the shellcode, and there are zeros in its place, and then it gets executed. It's very rare that there's not very rare, but it is more common that you'll have an actual address in RSI or RDI. That's the source and the destination register traditionally, and so they're used to, hold addresses often than RAX. Now, like malloc or some other thing that returns a memory address, the return value goes into RAX. But other than that, RDI and RSI, I've seen addresses in a lot more frequently, like the argument registers. All right. With that, let's take a quick look at the helpfulness. So last year's maximum helpfulness was 281. Samo's almost there. He's trying to speed run the helpfulness. Maybe he'll hit exactly 281 and then vanish. And then we'll start seeing the whole, like, oops, I raised my hand and the thing stopped tracking me. There we go. And then we'll see from there, everyone starts failing. No, I'm just kidding. I think you all have enough of a runway now to thrive. All right. Don't get discouraged by seeing these high numbers of these helpfulness legends. Zero Corral, Cody W, Rob was the one and only GDB and man page enthusiast, and then our Wicklund. They're getting a lot of extra credit, but it's a logarithmic scale. So if you get 4 extra credit, and I changed this from 2 to get people more hyped about extra credit, you just get 4 helpfulness, 4 thanks on the Discord, 2.4%. That's a quarter of a letter. That's pretty damn good. Even if Zamo goes over 9,000 in his helpfulness, you still get 1.52%. So these guys are fighting for the crown. Especially Robert, he just wants to beat everyone. Yeah, don't worry about getting less extra credit. Go help on Discord. And on that helpful note, we're gonna, unless we already did we? Let me pull up Discord. We were going to this morning deploy the forums. We got forum support. We didn't, but we will. It's gonna be good. All right. So that should hopefully make the help channels more useful, more searchable, et cetera, et cetera. And as a reminder, last week we abandoned this two-stage due dates thing. It was just a lot of code to implement. Konak didn't switch from his alt account. He's posting as pwn.college on the Twitch chat. Oh, he says they're not deployed yet. Still making those forums a reality. We're trying to automate their creation. Yeah. All right. Awesome. Good. Okay. So, baby jail is due as normal, 11 a.m. in 2 days. As you saw, the previous time bomb for releasing the lectures for new challenges have triggered. And those are available. Go watch them. And while you're, you tackle baby jail, tackle one of the jailbreaking challenges, let it kind of mull in your mind. Watch a reverse engineering lecture just to, spread your mental energy. And then you can maybe go back and it's Chmod. All right. And then after Thursday, you still can complete these challenges. They're just 50% credit. All right. Any questions about due dates, memes, helpfulness, etc.? Otherwise, I want to show a couple of things of namespacing, and then we'll just open it up to Q&A for the jailbreaking, because this is the second to last live session before the deadline. Can we go over baby jail level 6? Man, if you go over baby jail level 6, we're going to have a whole other video. Yes, of course you can, of course. We just won't, we'll try to keep it conceptual. Okay, let me show you one thing. Now, of course, just to clarify, I was referencing the whole thing where we had to make previous years of very helpful office hours private to keep some verbatim solutions from floating around. So we're trying for challenges after level 5, we're trying to give conceptual guidance rather than direct, like here's step 1, step 2, step 3 to solve it. But we'll go over it. Okay. So let's do one thing. And the one thing that we'll do is an exploration of namespacing. Let's pull up the little here we go. Wait. Oh, we didn't write it in C. We created a last lecture. We created on the console a little containerization thing using the command line, right? Let's spin up one of the new challenges. Let's see which one. Let's copy over. Why can't I? What's going on? Oh, there we go. All right. let's copy over the code from level 18, and I want to show you something cool. Oops, what am I doing? Okay, and then let's go to the SSH key. Okay, and then we will just scp hacker@dojo.pwn.college /challenge/start down here. Why? Why does SSH do this? Who cares if my public key permissions are world readable? Error in libcrypto. Oh, oops. No one is telling me that I'm loading my private key like an idiot, and that's why the permissions are matter. Or my public key instead of my private key. All right, let's grab this because this is just for to have the jail, and we'll remove this print disassembly stuff. Okay, a bunch of very messy headers, and here is the jail part. We'll remove this. We will also remove this. I shouldn't have just wanted the jail. Okay, here we go. The root is just going to be temp jail. And this is basically a C implementation, as you hopefully see now, of namespace based jails, right? Super cool stuff. So, oh man, this is going to be a bit of a pain in the ass. I don't want this level. I want a different level. Does level 17 require shellcode?
Yes.
Okay. 16 does too? Wait, I created 5 levels for you guys? Look at that. All right. Hopefully 15 doesn't. $16 does not. Okay. Let's do 16. Perfect. Just want one that's not super broken. Okay. Let's grab it. Remove all of these checks. We don't care about that at the moment. Okay. Mounted everything read-only. Mounting the old root directory. Okay, yeah, this should all be good. Okay, perfect. All right, and we forgot to change the jail path. It doesn't matter. All right, so we have a process in a jail. So now this more or less, let's say, implements Docker run for those that are Docker aficionados, right? We can wander around and we have our jailed file system, etc. Right? Now, one thing here is we can still view the files on my local machine. Here's my Chromium, etc., etc. Obviously, inside a Docker container, you can't do that. We explored ways to do it on the shell. But we can also, of course, do it here. If we also say, hey, when we unshare, let's do man unshare, man unshare system call, not unshare command. We just say, hey, clone a new PID group. And as we saw last lecture, boom. What? Oh, we didn't recompile. Boom. What? Okay. Oh, because we bound mounted / proc. So this is a very interesting thing that keep in mind. If we bind mount / proc, then we're just mounting this / proc directory with from our old PID namespace into the new PID namespace. And PSAUX, all it does is look at / proc. What we need to do here is remount / proc, and this is going down a rabbit hole. Let me just real quick see if I have this laying around somewhere. In what's going on? Okay. Okay. There it is. So if we, yes, now let's strace how this guy works. How unshare works when it's mounting a proc. What? Not unshare -f, strace -f. Okay. This is how we mount a new proc. So we're just going to copy this. And instead of this way of remounting the proc, we are going to make the directory. And boom, we mount the new proc file system. We forgot a semicolon somewhere. Okay. And now we run it. What the fuck? We do sudo jail and we're viewing. Okay. Let's get rid of this. This is disaster. All right. We're just gonna assert that this succeeds. Why is all of this? Do I need to fork after this? After unsharing the PID namespace? We might need to fork. And we keep the child, not the parent. Hmm. Okay. Unexpected. We might have to put this one on hold and unshare the PID namespace. This should freaking work. Compiled. Okay. Why did it die? Um, I probably died because no. Because sudo died. Let's just run this as root. Okay, there we go. Ah, yes. Okay, so things are almost working. Just that the child, the parent is. What's happening here? We're forking off a child, and then the parent has exited, and then our shell says, "Oh, the thing I launched has exited. Let's reuse the standard in, standard out for other things, and not wait for the child to exit." So what we're going to do is we're going to do this. Sleep. Nope, not. What is going on? Huh? Okay, okay. How am I kicked out of sudo itself? How do we launch the jail? Okay. If I hit enter, it kicks me out of my root shell from outside of the jail. All right, I think we're gonna abort the jail. I'm going to go back to our bash-based jail. So here was our root file system. We're going to ns. We're going to, let's see what I just, I think I just, whoops. Connor, you might, oh no, that cookie's dead by now. I just leaked the cookie on my, for my, yeah, good. Cookie's dead. All right. See, that's the problem of streaming on my laptop. Okay, anyways, let's do the NS Center based approach. God damn it, here it is again. Where's my freaking, oh no, the, we, hold on. Okay. Our unshare based VM here. And so we did unshare here. Okay, now we're here. We do old, we do pivot root. Oh, we do mount dash o bind dot dot. We do pivot root. Okay, now we are boom. Oh, we didn't mount all of these guys before doing this. Okay, we unshare. Now we're in a new mount namespace, and now we do for we mount all of these guys except for old. Old doesn't exist. Here's our proc. Interestingly, oh, proc was already. Why is proc? Okay. Anyways, we won't dig into that at the moment. All right, now we do the pivot root. What does it want? Failed to change root. Oh, we have to rebind mount. There. Okay. Now we do our pivot root. CD slash. What the hell? Where's my bind? Guys, this is one of those teaching nightmares. Like half convinced I look down, I won't have pants on. Okay. Okay. Dash dash bind. Maybe it has to be a different way of bind mounting. I don't know. Bin fucking exists, right? It's here. Okay. And if we go from outside of this freaking thing and we do ls bin, it doesn't. It didn't mount. All right. So now we do the pivot root. Pivot root into here, into this. Oh, we have to mount dash dash bind dot dot, and we pivot root wtp/r old. Okay. And everything got fucking unmounted. What the fuck? Fun fact, when you don't have ls in a shell, you can still list directories by using shell globbing to your advantage. You do echo star, it expands the star, and then it is similar enough to ls to at least let you look around. Extensive swearing is where we're at right now. Dude, I'm completely confused. All right. Luckily, what I just realized, what I wanted to show you doesn't. If you want to see me do this right and not like an idiot, look at last week's lecture where I guess the stars were aligning better. And I'll figure out what's going on, but you don't have to waste the rest of class time. We're already 45 minutes into class, and I haven't shown you what I wanted to show you, like real quick before diving in to Baby Suit. What I want to show you is that you can enter this namespace from the outside. So we're gonna leave this namespace as fucked up as it is, with no shell or whatever in here, and then we're going to create another terminal. And I am going to show you. Okay, this guy thinks he's PID1. That's a blatant freaking lie. But let's look at what PID it likely is. It's probably this guy. It's a root shell, right? And if you look in /proc, /this, there's a really interesting, well, first of all, before we show this, let's say I wanted to jump into that same shell. So we created Docker run, even though this is like Docker written by literal monkeys. And we want to do Docker exec, which goes into a running Docker container and launches a command. Now, what does that do under the hood? It goes into the namespace configuration of basically PID1 in that container and assumes the same namespace and starts executing stuff, right? The way Docker exec works is using something called setns. It's a system call that you give a file descriptor representing the namespace and the type of namespace, and it sets your process's namespace to the namespace that you provide. All right. So, what does this look like in practice? It's actually there's a bash command called nsenter. It takes a file. Let me just remember. It takes a file, and we can say, hey, enter the mount namespace of proc this dude. ns in /proc. There's a directory called ns with a bunch of files in it, socket files representing the namespaces. Mount. So we're going to enter the mount namespace. -- mount equals. And we want to launch something, bin bash. I forgot we fucked up the mount, so I can't demonstrate this easily. Okay, no, we can. Hold on. Don't panic. Okay, here we go. We have our flag. Boom. And we have our hello.s or flag.s. Do we have a flag.s already? Please just tell me we have a freaking flag.s. Whatever. Read flag.c. It'll just be a statically compiled C program. So it's going to char buff 1024, and then it's going to write standard output, the buffer size that's returned by read, standard input, not standard input, from the flag. Into the buffer, 1000 bytes, boom, done. gcc-static-o read flag.c. Okay, let's launch read flag. Beautiful. All right, why does it say hi? Okay, my flag is high. Good. Okay, great. So now, even from this stupid thing, I can do read flag, and I get my fake flag. All right, everyone loves the fake flag. Okay, now, if we do this nsenter, and I say launch, I enter its mount namespace, and I launch read flag, boom, flag fake. So I can join an already running namespace and just get in there, look around, do stuff. Like this is how Docker exec works and a lot of the other kind of introspection Docker commands. If we strace this guy, we can see that it is using, let's go up. At some point, set ns. And that clone new ns, that's entered the mount namespace for the process. And it opens its namespace directory, or its namespace socket file. If we look at what this looks like, you're familiar with proc_blah_fd for all of the open files and so forth. Proc_blah_ns. These are analogous. These are Unix domain sockets. They represent network connections locally within a Unix system, and allow you, in this case, to interact with that namespace by entering it from your process. All right, now, you might have noticed that we entered the mount namespace, but not the PID namespace. All of these different namespaces are independent. They're different subsystems in the kernel, and you can enter and not enter them as you want. So we could also do --PID equals blah, blah, and it'll also enter its PID namespace. But you could have multiple different processes in overlapping but not completely identical namespaces to implement, I don't know, crazy, complex sandboxing stuff that no one really does in the real world. Well, I'm sure they do somewhere, but typically not how Docker works. Now, Docker actually does let you enter some namespace and not others. So if you do docker dash help, and we go namespace, we can choose a specific C group namespace, for example, to join. Those are system resource limits. We can choose a specific PID namespace to join, a specific user namespace to join, and so on. And you can even say, somewhere, but we're not going to try to remember how. Yeah, you can do, I think, dash network host. No, that doesn't quite do it. There's a way to say, hey, actually just don't even create a new network namespace, use the host's network namespace, stuff like that, right? And that's under the hood, it's all this namespace magic, like what nsenter allows you from the shell, and set ns gives you from, nsenter uses the set ns system call to accomplish that. Now, what's the implication of this? The implication of just needing a file, just a socket file, and the right capabilities user-wise to set your namespace means that you could potentially, just by grabbing a handle to a different file from outside of your jail, escape that jail. And in this case, I used it to enter jail. But if I do something like, instead of a read flag, escape.c, can just do set ns open. And how about escape hatch will be the file name, and we'll do clone new ns of what we will. It's clone new ns, right? Yeah, perfect. Okay, and we also need to include scat.h for that that guy, and then define GNU source, or it won't actually create this this constant. Okay, and then we do create a static directory with that. Oops, my bad. Open should be here, and then colon ns. Okay. Okay, and of course, then we need to do something like execl. So we're now going to try to break out of our mount namespace, and then we should once again have a fucking functional shell. And then we'll just run bin bash -b, and we'll be golden. All right. Beautiful. Now we will run escape. No good. Oh, fuck. God damn it. Okay, we create our new mount namespace. We mount them all. Okay. Oh, fuck. Okay. That fucking worked. Okay. All right. Then we. Oh! Did no one. Was I just ignoring people that pointed out? So when I do this, I wipe out. No, I don't. Anyways, I think I have to do that before this guy, and now everything will work perfectly. I hate computers. I could have been like, I don't know, like a happy person, you know, like joy. Joy was possible. Okay, now we pivot root. Aha! It works. We have a functional freaking. All right. Lesson learned. Make sure to make your mount point, your directory a mount point early. Okay, we need to go and then do this. Do number 6. All right. Let's focus. Okay, so now we run escape. It gives us another shell. But did we actually escape? No. Flag is still fake. Why did we not actually escape? Anyone remember our escape.c? Why didn't we escape? There's no such thing as escape hatch yet. All right, so now we need to get the escape hatch. If we trace this guy, we can see that what it did was, where's our set ns? Where's our set ns? Oh my God. Boom. It tried to open the file. It got a -1 error. And then it tried to set ns that file. So we just need an escape hatch. So here we go. From above, we go into /proc /us. This is now outside of the jail. /ns. Here is this mount. We copy the mount domain socket into our jail. Oh, we can't copy it, but we could. This gets a little. Actually, there's this copy. Can we? You got to be able to mount these. Is it just for you can't copy them? There we go. You just have to be careful how you copy. CP-A means copy as an archive, preserve everything you can about it. It allows you to copy some more files. There's another flag that is actually the correct flag to use, but -A uses all source flags. Now we have our Unix domain socket in there. If we rename it into escape hatch and we hit our escape, boom, it didn't work. That's fine. We trace it to figure out why. There's a perfectly valid explanation. It's right freaking there. Escape. Did I misspell escape hatch? I wonder if it's no longer valid somehow. That doesn't make any sense to me though. Okay, let's do something a little. Can we really not open it? What the hell? We don't need to suffer over here. We can suffer like normal people in normal VI. We open the escape hatch. We assert that FD is greater than 0. And then we do FD here. And we assert that this works. What? What do you mean? Oh, we didn't include assert.h. Okay. Then we run it here. Huh. Going to have to look into this further. I wonder if I have to fuck. All right, well, either way, we're moving on. Interesting. I think moving that socket must have screwed it up, but I don't quite know off the top of my head exactly why, but we'll figure it out. Anyways, what I wanted to, we had a request on there are ways without copying things to get these namespace sockets. And once you have a way into a valid, unmessed up namespace socket, and you can run set ns, boom, you're all set. Obviously, this wasn't the way. Now, let's look at level 6 real quick. But I want you to really see a lot of these gotchas we run into that ate up an hour of my time. Please don't leave things to the last hour to do, right? Even if I left my own challenges to the last hour, I might not have solved them. I, of course, have solutions for all of these because we have solutions for all of our challenges to make, because some of them have randomization. We have to make sure that with randomization, they're still solvable. But it's you know, very important. Little things can trip you up, as you already know from Baby Shell, but here it is a little thing in a massive, massive haystack. All right, let's run Baby Jail level 6 and see what's up. Actually, let me launch in practice mode so we can look in the jail freely. And then we'll go from there. Okay. Set up the workspace. All right, what is Baby Jail? Typical thing, it's ch roots in. We may specify a file, and then we upload shellcode to do things. So, what happens? We open the file right here. Okay, we assert that flag isn't part of it, and then we open it up. All right, that happens before any jailing. Then we create our jail, and we are able to execute the following system calls. All right. Open, read, and write, and send file. That's, of course, how you open the flag and send the flag back out to us. So the big thing here, if we copy this level into our home directory and we go back and we ask ourselves, what is the difference between this level and level 5? Okay, now we're in level 5. So if we diff BabyJ level 5 with BabyJ level 6, just one thing, level 5 had link at, level 6 has FCH there. So if you did level 5, of course, link at is similar to open at or whatnot. It's one of this new generation of system calls that takes a directory file descriptor as something that you can pass in, and one of these file descriptors is the challenge allows you to create a file descriptor as part of starting it up, right? So, of course, or to open a file. So you open a directory in level 5, right? And then you say, hey, relative to this directory that's outside of our jail, let's get the flag, right? So that's link at. Now, what does fchdir at do? Or fchdir? Fchdir is like chdir. Chdir changes your current working directory to a path. Fchdir changes it to a directory represented by a file descriptor. Right? And again, you can create this by running. Now we're in level 5 technically, but that's okay. For this demo, it'll work. By doing something like this, right? We strace this, and we look at what it does. It opens my /home, which is a directory, and gets a file descriptor for it. So now that file descriptor can be passed around. In link at, that file descriptor can be abused to make links, including hard links. With fchdir, I can use that file descriptor to change the current working directory. All right? And this file descriptor can be outside of the ch root. So now the question for you, which you should have already explored earlier in the levels, before level 6, is what can you do with a current working directory outside of the ch root? All right. We have 4 minutes. Again, sorry we ran down several different rabbit holes. I swear I just wanted to show off set NS and how cool it is that you can jump into these things. But we ran down way too many rabbit holes. Actually, I just realized, why don't we just set up one more namespace real quick? This time it's gonna work. I know it. And then we'll just it'll be good. So let's do this. NS enter. God damn it again. Unshare. Okay, now we do the mount. For x in star. Okay, boom. And I want to do one more. Escape room. I guess this whole thing is an escape room. But I just want to bind mount /proc/ this guy /ns into ASDF. Okay. What? What do you mean special device doesn't exist? Oh, what? Oh, we're already on a separate mount namespace. Okay, never mind. That also failed. We should have gone with the C approach, which is more flexible than the shell approach. Yes.
Can I just say this is all just like a living meme for us doing every one of your challenges?
Yeah. Comment.
Why isn't this working? It's supposed to work.
Yeah, exactly. Yeah. It's this happens a lot. A lot of my like the pre-recorded videos where I do like live things on the command line. Each of those took many tries, and there's some where it's I'm gonna pause the recording, figure it out, come back. Yeah, it gets crazy, right? So even and you saw this in the World Championships of Competitive Hacking, DEF CON CTF. They ran a really interesting thing this year, which was live CTF. And so what they did, and we can just search for live CTF. It's all online here, but then there's their website. Go here, and then let's click through livectf.com. All right, so this was one part of the World Championship of Hacking this year. They wrote challenges and pitted top hackers, like people that were invited to compete in Las Vegas, and had them go head to head in a hacking competition with what was intended to be easy challenges. And then there were challenges that hackers just didn't solve. You can, if you're interested, go to livectf.com, and a lot of this is going to be very familiar to you. GDB output, et cetera, et cetera. And you can see how these hackers approach these things. And you can see with a commentary by the commentators the trivial things that some of them miss, right? Even the top hackers do it. So there's no hope for a noob like me, of course, in live in class. But over time we figure it out and it works. All right, awesome. So we will see you guys on Thursday. Actually, Robert's gonna have his office hours tomorrow, so please drop in there. In the meantime, if you're really stuck on things, feel free to always ask on Discord also, but also ping us directly if the need is dire. All right, good luck.